Yeah.
So some scholars may worry that some factors in blood, such as growth hormone, might provide short-term improvements, but may have
Yeah.
long-term, like maybe causing cancer. What's your opinion on it? Will it risk?
You
Will
know,
there be?
typically with female rats, they all develop mammary tumors. None of our rats develop mammary tumors after treatment. None of our rats developed cancers or tumors of any sort. Uh, this is a natural method by which the body causes cells to be young. Uh, of course, now exosomes can, in fact, and are, in fact, produced by cancer cells in large amounts, and they do cause uh, cancer processes. So we have to make sure that our pigs are cancer free. But you don't see cancer in young pigs in any case. Um, pigs are normally slaughtered at about 6 months of age, which is again is equivalent. It's not linear, but it's equivalent to about early adolescence.
Hmm.
Speak in terms of life stages rather than ages. Uh, and of course, their blood is just a byproduct. Now, I understand that Chinese people, at least in the United States, do drink blood as a sort of a porridge. Uh, and they do make blood into many cultures. European cultures do make blood sausages using the cellular content of blood to make sausages. But it's a very small market. So basically, the pig blood is just thrown away or sold very cheap to be used as fertilizer. Uh, it's an industrial byproduct of the pig industry. But we've managed to spin it into gold. And so so that's it. So it really means in this world there are 1.4 billion pigs killed every year. The world population of pigs is estimated at 650 million, but they have large litters and they keep on having them. So there's a continuing supply. And honestly, not a single pig would have to be slaughtered for our process. Just what's thrown away would now be used to make basically to make old people young again, or to keep young people young. In your case,
So when
uh,
it comes to, please go ahead. Yeah.
no, go ahead. You go ahead.
So when it comes to using young blood to rejuvenate the elderly, should this, blood entirely be donated by young people?
But
Will,
no, it should
will it?
entirely be donated by young pigs.
So if one day this technology will be, it will be used on humans, maybe. You
Uh,
mean still the
that's our
blood can?
plan.
Oh, I see. Still the blood can be donated by the pigs.
Yes, yes. This was pig blood. This was we don't use anything other than pig blood. We tried cow blood.
Mm.
Of course, we were working in India, and using cow blood is about the same as asking somebody to use their grandmother's blood or their children's blood to. So we tried water buffalo, but we had no success. It doesn't mean it won't work. Uh, if we have a little more funding, we can perhaps do a better job with cows, because there are about 2 billion cows. And the nice thing is you can extract blood from the cows without harming the animals, which would be my preference. But there are some ethical concerns, but I think nobody, pardon me for saying this, but I think nobody in China is going to stop eating pork on a massive scale. So there'll always be a supply of young pig blood. And the numbers are sufficient to support all human beings without establishing a black market in young human blood, for example, which would be a horror. And the pigs are still made into sausages, and the farmers lose nothing, except they'll probably get a much higher price for their industrial byproducts.
What about the dosage to infuse every time? Is there a
Well, now you see that's the problem. That would make it very difficult to use human beings for, because the dosage is pretty high. We use about 4 times the human volume of plasma to produce enough E5 to rejuvenate. Well, we use 4 times the rat's volume of plasma to make enough E5 to rejuvenate a rat. So since young humans are smaller than older humans, we'd have to up that, maybe sacrifice
pigs?
8 to 10 young people for one old person. And I don't think that would go very well. But with pigs, they're sacrificed anyway.
Yeah. So compare with the stem cell therapy, stem cell therapy is also very popular anti-aging intervention, right?
Yeah,
How does it?
stem cell therapy. Uh, there is a researcher uh, at Albert Einstein University in New York. A friend of mine graduated a medical school. It's not a university; it's an Albert Einstein Medical School. Uh, called Cai Dongsheng. Uh, he spells it CAI. So
I,
we would pronounce it Kai, but I'm told that in Chinese it should be pronounced Tsai.
yeah.
Yeah. So Tsai Dongsheng tried improving the cognitive function of rats and the lifespan of rats, or mice actually, um, using stem cells. He found that the stem cells, in spite of the fact that the mice were a particular breed that would allow stem cells to be implanted from a different mouse, so they were immunoincompetent. He found that the stem cells died in any case when they were injected. But he found that the products of their secretion were able to rejuvenate the old rat or mouse brains. So he went a step further and he raised neural stem cells in culture, and he just used the culture medium, which is called conditioned medium. He just used the conditioned medium, which contains the exosomes. He purified those exosomes by standard techniques and injected them directly into the brains of the mice, into the third ventricle of their brains. and he had exactly the same effect. And in fact, he increased the maximum lifespan of the mouse by about 10 to 15%. We do better than that, considerably better. We increase, but I was worried about him. He's smart, and he certainly was on the right track. However, I suppose, lucky, and our method worked. We increased on average. We decreased the age of our old rats by 54%, according to Steve Horvath's DNA methylation clocks. And we had corroborated all our other results. Because we performed about 30 tests on these rats having to do with cognition, organ function, etc., and cellular functions. And in the liver, for instance, we reduced the age by about 67%. So it varies by organs. Our least rejuvenated organ was the hypothalamus of the brain. But in terms of cognition, we reverted the cognition of old rats, which is pretty poor, to those of young rats, which is, I mean, good for rats. We used the Barnes maze to test that, where they were given a kind of puzzle they had to solve. And the old rats, untreated, never got any better at it. And the young rats, of course, got better at it. And the old treated rats got to be as good as the young rats at this cognitive task. So we know it works on the brain, but it seemed not to work on the hypothalamus. And that's a problem. One of the things that I would like to work on. I have my own ideas about how to do it. So, and we're also interested in what causes the maximum species lifespan. That's something else. We've already exceeded it. A rat SEMA that you talked about, it was in The Guardian, the experiment. SEMA is a Hindi for limit or boundary. And we called her SEMA after she exceeded the age limit for old sprigged oily female rats, and exceeded it considerably. So SEMA was not our first experiment by any means. We had already shown that we could rejuvenate rats multiple times. In this case, we changed the cycle. We first started rejuvenating them every 90 days, which would be equivalent to about 8 years in human terms. Then we went to every 45 days, and that seemed to extend the maximum lifespan of the treated rats. And we suspect that if we went even closer, humans would be perhaps every year, we could just keep them young as long as they wanted to be kept young. So it's it's not like once you've taken this therapy, you have no choice. You'll continue to age, but you'll start out as a young person and continue to age until you get your next shot. And you'll go back or stay young, depending on the frequency. So it's pretty exciting, and it should change the world in a major way.
Yeah, will be soon be used onto humans. So
Oh,
really
yeah.
thank you for detailed and patient interpretation on the question.